Hi, my name is Kevin Gutierrez, and in my back of the napkin assignment, I will be explaining heat exchangers. Heat exchangers. So, you might be asking, what exactly is a heat exchanger? Well, a heat exchanger is a device which facilitates the exchange of heat between two fluids. It is not like a mixing chamber. The two fluids do not actually mix and are separated by a solid. So one fluid would be on the one side of the solid, fluid 1, and one other fluid would be flowing on the other side. The method that these fluids transfer heat is through a temperature difference. So the main formula is as follows: is the heat exchange is equal to the surface area, the heat transfer coefficient, and the change in temperature between the two fluids. So you might be asking, what is a heat exchanger useful for? Well, it is used in transportation, heat and air conditioning systems, chemical processing, medical devices. It has many uses. So one of the uses that you might be most accustomed to seeing in your everyday lives is in a car. The engine of a car produces massive amounts of heat that needs to be cooled in order to operate properly. So it has a radiator. A radiator is a cross-flow heat exchanger and is able to effectively transfer the hot heat from the engine to the cool air. So, as I was saying, in classifying these heat exchangers, there's two ways they're classified. One is geometry, and the second is flow type. So geometry, there's double pipe. 2, cross flow. 3, shell and tube. And 4, plate type. And for the flow types, there's two different flow types. One is parallel flow, so the two fluids are flowing with each other, and then counterflow, which the two fluids are flowing against each other. So to give you a better idea how an arrangement would work, I'm going to be drawing out a double pipe counterflow system, which is very commonly used in industry. So a counterflow system would look as follows. One pipe would envelop another pipe, as so. So one pipe would run inside the other, and cold fluid, for example, would be the inner pipe. The inlet would be cold and would result in a higher temperature as it flows through, because this hot fluid would flow against it, thus imparting some of its energy to the colder fluid. This is kind of how a double pipe counterflow heat exchanger would look, with the flows going against each other, and the resulting cold fluid would result in a higher temperature, and the hot fluid would result in a lower temperature, imparting some of the energy to the colder fluid. So in order to classify how effective a heat exchanger is, there is a formula: effectiveness, which is equal to Q over the Q max, which is the theoretical maximum that the heat exchanger could operate in. And this is the reason why a heat exchanger does not reach this theoretical maximum is due to resistances in the pipes, such as friction, and fouling, which is rusting of the pipes over time. I hope you learned a little bit about heat exchangers in this little presentation. Thank you.